What is happening, guys? What's going on? Oh my goodness. We're back. We're back for day 3. The final day of keynotes at KubeCon 2019 in San Diego. Thanks everybody for joining throughout the week. It's been a blast. We've had some great presentations. We've had some not so good presentations, but so far, I think the takeaway for me has been, and I'll share more of this tomorrow on our big weekly stream. Friday at noon, make sure you're clicking the heart up above on the channel. Make sure you're following us so you get those notifications when we go live. We're going to be doing a lot of this over the course of the next year and beyond, hopefully. Here on the DatacenterDude channel, we'll be doing some technical practitioner type of stuff, but also we're developing some ongoing recurring content over at twitch.tv/NetApp. Make sure you're following that one as well. But yeah, thanks for hanging out, guys. Thanks for coming on and joining us. We're going to hang out. We're going to watch the keynote together. We're going to react together. Be sure to weigh your opinions in the chat. Let us know what you think. But we definitely want to hear what you guys have to say about KubeCon. My initial takeaway so far has been it's a little bit amateur hour, and it's kind of showing that what a new thing this whole ecosystem really is, especially as the enterprise starts to make its way into it. You're going to have a lot of people that have been doing infrastructure for 20 years. Myself is a great example of that are still learning about cloud. But you're seeing like new presenters and new people, and we don't know who any of these people are, outside of the vacuum of the cloud native bubble that's you guys have lived in for a long time. So share yourselves. Let us know who you are. What are your products? What are your projects you're working on? We need to know what all of these things are. It's as much a dog and pony pitch show as it is, welcoming of a whole new community to come in and be a part of this thing. So we want to come and play too. Let us in. But there's some learning to do, I guess, is my big takeaway. We all got some learning to do, especially those of us coming from the infrastructure world. We definitely have some things that we need to work on in that respect. Getting the last couple of things set up here. We're just a couple of minutes away, about 30 seconds away from getting started here. I'm going to switch the music over to the actual live stream music. Woo, that's really loud. Need to make sure I got these going on here. Turn that off. All right, bear with me 1 second, guys. Do I not have the right setting? Yep, that's right. Well, why isn't the audio coming through? Oh, good times, good times. Let's switch this over. See if we can find this real quick. Bear with me 1 sec. Boop, 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 boop. Bow, bow. Bow, bow. Nope. Oh, I hope I can get this done before the start. I know it's registering. Nothing's changed from yesterday to today. Oh, that's why. I found it. Yay! It's always the simplest thing. The volume slider was turned all the way down. There we go. All right. Make sure we got the right one. Let's go.
All right. Let's see.
Let's party.
Good morning and welcome to the last day of KubeCon/Cloud Native Con.
Woo!
Before we go into the keynotes, a quick reminder about our event code of conduct. All attendees should feel welcome and included. If you have any issues or witness anything, please talk to our event staff right away. And seriously, do that, please. Over the last 2 days, we focused on this overarching theme of how our ecosystem has matured. Well, Tuesday focused on how our projects are growing more advanced. Yesterday focused about how our use cases are growing more advanced. And today, we're going to try to bring that all together to discuss how these advancements allow our end user communities to do more advanced things. I'll kick us off this morning by exploring what the landscape could look like with more developer-friendly tools and systems in search
Trying to watch it 30,000 feet.
Rails moments. So the interesting thing is,
Todd, I think you can turn the quality down with the gear down to like 360 or something like that.
Than me, so
that might make it easier.
Let me do this properly. Our next speaker hails from Maryland, where he practices on, he likes to do computering things. He's worked at a bunch of businesses, and he is definitely a purveyor of justice over civility. He is the greatest speaker of all times, and please introduce to the stage the most amazing man in the world, Brian Lyles.
Well done.
All right.
Well done.
So,
much better kickoff to day
I'm
3.
Do a keynote. And so this is an interesting
160p.
topic.
I hear you.
I started on this idea months ago, and I said, well, this is probably going to be on the last day of the conference. What could I say that would really irk the most amount of people? So my title today is called In Search of the Kubernetes Rails Moment. And in case this is not clear, I'm talking about Ruby on Rails.
Came and went.
So who is this guy? Well, I'm introducing myself a lot today. I am Brian Lyles, Senior Staff Engineer at VMware, and I like alliteration. So celebrating the hip-hop culture, cars, computers, and creating a better world. That is what I am about. But really, I want to focus on this first item, celebrating the hip-hop culture. And what I'm going to present to you, without actually even saying it, is this talk. And this talk is hip-hop. And you're like, what? We're going to do a talk on hip-hop at a Cloud Native event? Yeah, we're going to do a talk on hip-hop. And what I mean by hip-hop, and what you probably think of as hip-hop, is music. Like that song that I walked into multiple times. That song is actually entitled Hip Hop. And the reason I chose that song was to craft this particular message right now. Hip hop is not just the music. Hip hop is DJing. Hip hop is basically emceeing, which I am doing right now.
It's dance.
Hip hop is graffiti. The graffiti art is hip hop. And hip hop is b-boying. We'll get into that a little bit later. And the reason I bring that up is because I think it will actually tie this together. The first lyric of that song is, when the music hits you in your brain, you will feel no pain. And I'm going to tie that into Kubernetes is that when we get our jobs right, when we actually figure out what we're doing, our community will feel no pain because we've fixed that. Our companies will feel no pain because we are able to execute in a better fashion. So my whole life, this revolves around hip hop. And since I'm up on the stage, I spent some time over the last year writing an application that is open source. I was like, well, why not I talk about it for a second? So I am the project lead for this tool called Octane. And the reason we created Octane was because when I talk to a developer and I say, what is your problem with Kubernetes? And they're saying, well, I don't really know what's going on. So the premise of Octane was, instead of asking our users to figure out what's going on, why don't we just tell them? Believe it or not, we know computers, and we can tell people how to solve their problems. So check out Octane. It's pretty cool. Got a lot of great response from the project here, and I'm just super happy to be able to share it. So on to the talk. And forgive me for the flashing thing, but this
epilepsy
right here, this video is the start of a moment. This video came out in 2005, and it's the Rails Oops video. So David Hannemeyer Hansen, who I will refer to as DHH for the rest of this talk, created this blog post using this brand new web framework he called Ruby on Rails in this video. And the best part about this video was every 30 seconds he would go, oops, oops, oops. But at the end of it, he had a fully functioning, albeit poorly styled, web application that could serve as a blog. In that moment in 2005, going into 2006, actually changed how we think about writing software. So with Rails, we didn't really bring anything new to the table. It used this old esoteric Japanese programming language called Ruby. But what Rails brought to the table was this idea of convention over configuration. And that's what we're going to dive into in this talk.
Interesting.
So how does Rails and Kubernetes actually relate? I don't know. And what lessons can Kubernetes learn from Rails? So just to put it out there and, pat ourselves on the back, according to GitHub, Kubernetes is beating Rails by watchers and stars and forks. So what really can this project that is actually way more popular than Ruby on Rails learn from Rails? Well, let me go into this really interesting idea. Like, we're on a whole new thought here now. So I don't want to actually push anyone out, but this right here is YAML. We love YAML, right? You're kidding. You're saying that to make me feel better. No one really loves YAML. No. But I wanted to show this piece of YAML here. So this is a deployment for installing Nginx into your cluster. Kind of neat. Well, let's actually pick this apart a little bit. So on a line there, and I actually have it crossed out now, if we only want one replica, why do we have to specify replicas? Let's get rid of it. Well, what if we, so here's something that really is, I understand why it is in Kubernetes, but there's duplication inside of the YAML because we actually specify selectors and we specify the pod labels. And I know the reason why we do this, but you know what? Let's get rid of that too. Why don't we just assume everything is port 80? And there are definitely good reasons why not to assume everything is port 80. But since we're deleting things, let's delete that too. So is this convention over configuration into Rails? Can we just introduce more conventions into our
I like where this is going.
To make it simpler? Well, we could. But maybe you want a liveness check. Is this thing actually going to run? Well, we'll add that. And I want a readiness check. This thing is ready to serve traffic. I'll add that too. Want to access the volume because we have config data that lives on a store somewhere? Well, put that in there. I want to access secrets? Well, we're putting things in there. Might as well put something else in there too. And here is the greatest troll in the Kubernetes ecosystem right now, pod affinities and anti-affinities. That's how you would do a pod affinity and anti-affinity. We'll add that in there too. And what we're seeing now is that just having the idea of conventions doesn't make anything simpler. And and we really need to think about how can we embrace this concept of Rails into Kubernetes. Well, just stripping out features is not going to work. So here's something that isn't said often enough. I hear this a lot. I see it on social media. We're not using Kubernetes because it's complex. Well, let me share something with you. Kubernetes runs on bare metal. It runs in VMs. It runs in other people's clouds. It runs on your Raspberry Pi. Kubernetes supports multiple types of container runtimes, multiple types of networking runtimes, multiple types of storage runtimes. And guess what? People are shipping this software today. Kubernetes complexity is necessary complexity. So when someone says it's too hard, it's just because, frankly, they're selfish and they only think about their particular problem. We need to create problems that help others. So how do we capture the essence of Rails without diluting the power of Kubernetes? Because we don't want to do that. We don't want to be selfish. So I just can't help but talk about more YAML. And just because I'm on stage here and I'm giving the keynote, I'm going to redefine some terms. YAML is for computers. It's not for humans. Humans can read it. That's cool. But YAML is for computers.
Hamel.
So because I'm up here making things up, since YAML is for computers, we'll just consider YAML as assembler, because that's not a problem, is it? And because I love taking analogies and metaphors too far, let's write some assembler. This is 8088 assembler, not confused with 65 assembler or MIPS assembler or Spark assembler or anything like that. I got to make this fit on a slide. So we're going to write a program real quick. We're going to take 13 hex and we're going to move it to our AX register. We're going to call interrupt 10. And then we're going to move a 8000. And I know that's not how you say it, but I like saying 8000 instead of A000. And then what we're going to do is we're going to move AX to ES. And we're going to move 0 to AX. And then we're going to move AX to DI. And then we're going to move 7 into DL. And then we're going to do something even crazier, is we're going to move DL into ES:DI. What have we done? Well, really, we haven't done much. We put a pixel. Well, we changed our screen resolution if we're running DOS to 320 by 200, and we put a gray pixel in the top left-hand corner of the screen. Not descriptive, not helpful, but this is how we used to write software. I started writing programming in C, and my second thing that I got to touch was TASM. So I actually thought this is how we wrote computers. This is how I thought we computed. But it's not productive. We've learned lessons since then, and we can actually do things at a higher, this is the same kind of code, and it's Python for Windows. But what if I'm running a Mac? This is not helpful. What if I'm running Linux? This is not helpful. So why do I show that? Well, I show it because just working at the level of YAML isn't really what we want. We want to work at higher level. But what does that higher level look like? I don't know. So here's where I want to be. And I know a lot of my friends out there have tried to do this. I don't want to write YAML. I want my app to say, hey, computers, I'm coming. Get yourself ready. But really, I mean, that's what you all want too. But because that isn't happening, we're all employed and we're here talking about this thing.
Right-click on an app, properties, check,
we want to solve bigger problems.
Apply, OK.
And now I want to do something else, introduce you to some other terms. LLVM.
There's a reason wizards exist and property menus exist.
When LLVM started,
still today,
it was called the low-level virtual machine. Right now, do you know what LLVM stands for? It's LLVM. They're like, screw it, no one can get it right, so we'll just call it LLVM. It's like it's a fun note. But LLVM is interesting. What it is it's a system where you specify a front end, and then you have an optimizer that optimizes, and then you have a back end that does back end stuff. And generally that back end stuff is you create machine level code. So depending on the platform, x86, x64, ARM, ARM64, MIPS, Z architecture, it can do all that. So what's on the front end? It's our programming languages. Besides Go, it's funny, we use Go, but Go doesn't use LLVM. And I think it should use LLVM, but it doesn't. But it's a Google thing. So things like GCC, things like Julia, things like the Haskell LLVM compiler, they compile to this front end. And they produce all this on the back end. How can we actually learn from this? Or actually, before that, I'm going to tell you why we have LLVM. Some smart people realized that with we were solving the problems again and again and again, and not the same way and not well. So we would have this problem where we needed to have some optimizations, or we wanted to have an interpreter, and we wanted to be able to do some just-in-time work on it. Or we wanted to have an output, and I wanted to compile this thing, and I wanted to have ARM and x86-64. LLVM helped us solve that problem. Now, as a language developer, I don't need to think about that. I can just write to this front end, and the front end will help us. But what can we learn from that in Kubernetes land? Well, we can take that front end, optimizer, and back end, and then what we can do is we can change the words. So our app and its intentions are the front end. Question marks are the
or
optimizer.
A user
and that's what we need to figure out. And the back end is the Kubernetes back end. And before I was saying that Kubernetes YAML was assembler, but maybe it's not assembler. Maybe it's machine code. And no one wants to write machine code or think about machine code. So how do we turn our app and its intentions into this machine code, AKA YAML. And that's what we need to figure out. And this is a keynote and not a tech talk, so guess what? I'm not going to tell you how to do it. I'm telling you to think about how to do it. And then I also want to remind you of this. Kubernetes is a vehicle taking us to our destination and not the destination itself. Too many times we focus on Kubernetes as a product. It is not a product. It is a fancy car. Is it an electric car or a gasoline-powered car? I don't know. But it is a car. So let's go back to this middle box. In this middle box, I just throw out some things. Wouldn't it be nice if we could just figure out how to automatically do CI or automatically do CD? Or even if you work in a regulated environment, how to automatically do auditing? And a lot of you have never worked for a bank or a health company and don't understand about auditors. But auditors are the people who mean well, but wow, you all, oh gosh. Yeah. And I'm not here to talk bad about anybody, but yeah, my friends who work in regulated environments know.
Yep.
And then this back end. Here's something else we don't want our developers thinking about. Generating YAML, applying security policies, they should just work. You know what the security policies are, apply them. Or network policies, you know what they are, apply them. Wiring up observability, you know, our developers should be developing, and should they be conscious of all of this? Yes, yes they should. But should we hold up development because they can't understand how to wire up observability? No, we should not. So, I'm trying to think about how to say this not controversially. Okay. Think about this. We have a horizontal line and we have a vertical line. The horizontal line, the line of the landscape, is our landscape. It's our ecosystem. It's all the projects and all the technologies that we require to be able to do what we want to do.
Yeah.
And this vertical line going up is all the organizations. It's the CNCF Platinum and Diamond and Gold members. It's the people who need to make money in this space. We cannot mess up the line. We have to keep the line straight. If all of our companies, what we should be doing is figuring out how to inject whatever goodness that we are going to inject without breaking the ecosystem. And this is one of the things that I love and one of the things that we actually were very conscious about when we're actually putting together KubeCon Cloud Native Con. You'll notice that none of the speakers up here really sold their companies. That's because them selling the companies is for the booths. Them providing enhancements is their business. We don't want to elide those, we don't want to push out those opinions here. We want the ecosystem to not be broken because one company needs to make money. There's plenty of opportunity for corporations to provide optimizations to our ecosystem without breaking.
You mean like how you didn't get up and talk about Octant, Brian?
So, Rails convention over configuration. Well, what does it mean? It means that basically, I'm going to give you a good set of defaults because I know what's happening. And this is the only typo on my slides, by the way. You can use them until you outgrow them. And you can change them, but you don't break everything else. Something else we can learn from Rails. Things we have should have good defaults. Rails is really good at defaults. Our defaults should be easy to override. And our primary job, second typo on these slides, is to find those good defaults. I'm senior staff engineer at VMware. My job should be called default, senior staff default engineer. You're a principal architect. You're the principal architect of defaults. Think about that. So, other things that Kubernetes can learn from Rails. And this will be fun. Pay attention because you're going to be like, whoa. Rails freed people from thinking about serving web requests, which led to people rethinking about the Sinatra project. This was this random Ruby project that actually allowed us to have Heroku. And when with Heroku, they actually led to us rethinking about how we thought about paths, which gave us a concept of git push Heroku master, which inspired Deus Labs to imitate that concept. And then, you know, yada, 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 Helm. And I can do it again. DHH developed Rails and TextMate, which moved developers to Macs to Max to use TextMates. Most of you all here using TextMate right now is because a Ruby on Rails developer thought it was a good idea. Think about that. And this led to the resurgence of the text editor, which ultimately gave us VS Code. Crazy. Thank DHH and Rails for that. I can do it again. Rails freed Mac users to think about other problems, which led to the creation of Homebrew. Homebrew is written in Ruby, that esoteric Japanese language, which is actually pretty amazing. Rails has inspired a whole generation of
this
developers.
Is awesome. I never knew all of that.
The box. And funny thing enough, Ruby on Rails got me on this stage right now because I met Dan, and we actually just realized we were both at the same Ruby on Rails event in 2006 together. Rails got us here. So Kubernetes.
It's important he brought up 2006 as an inflection point. I want to come back to that afterwards.
Better Kubernetes. And
because it matters
Kubernetes
today
on Rails
too.
Moment is making the ecosystem better. Because Kubernetes allows us to think about the more important things. You know, all these things we think about in Kubernetes are fine, but that's not the important piece. So we've been here before. Linux did this, which is crazy. We're not the first. Linux went through the same journey. So my call to action is, let's make Kubernetes enable our journeys. Let's find Rails Kubernetes moment. And just to make sure that I'm ending this on hip hop, I used to be able to do that. Thank you. All right. So I am no longer the speaker. I am now back to the host. And so our next presenter is Ian Coldwater. Ian Coldwater is a grown teenage hacker turned lead platform security engineer at Heroku, who specializes in hacking and hardening Kubernetes, containers, and cloud-native infrastructure.
So one of the things I get hung up on pretty often
and
while he's introducing the new stuff here. 2006 is a huge year for the industry as a whole. It's where I saw my first vMotion. It was the beginning of the rise of VMware. And it's interesting that he was talking about 2006 for developers, because one of the thoughts I have coming out of this is that KubeCon is developers speaking to developers.
Thanks to CNCF for having me.
But we all want to come play now, and it's a weird, awkward situation. Back to this.
I love you. This talk is about looking at Kubernetes from the eyes of an attacker and what we can learn from that perspective. My name is Ian Coldwater. As Brian said, I'm a lead platform security engineer at Heroku, a Salesforce company. I specialize in hacking and hardening Kubernetes, containers, and cloud infrastructure. Before I came to Heroku, I was an independent penetration testing consultant specializing in the same. Penetration testing is people pay me to hack into their systems and break them. I write reports, I tell them what I found, how I got in, and how they can fix it. I've been penetration testing Kubernetes since the days when you could execute commands as root with an unauthenticated curl call, which was a while ago. It's come a long way. I've watched the project and its security posture evolve and improve over time. I was trying to figure out what I wanted to say in this talk when I was talking to absolutely everybody. And the first thing that came to mind was, hi, community. Y'all are amazing. Look at this. Look at all of you. Look at everything we've built here. That's awesome. Kubernetes is a project that's powered by its people. And that same sense of openness, trust, and possibility that makes this community such a genuine joy to be around can be seen reflected in some of its design decisions. These design decisions aren't unique to Kubernetes. They can be seen in projects all across the CNCF landscape. And in a lot of ways, that's gone really well, clearly. It's resulted in Kubernetes' huge rate of growth and rapid adoption. It's gotten a lot of people up and running without necessarily having to do it the hard way. So let's look at this, though, from a different perspective. Because it's been said that people tend to build systems that reflect their organizations, their processes, and sometimes themselves. They tend to reflect the perspectives and contain the biases of their creators. This is why it's so important to have diverse teams and to design for diverse sets of users. Because diverse teams that keep more perspectives in mind can help to build stronger systems. When we make assumptions that others are like us, that they share our biases and our perspectives, sometimes we can miss things, and sometimes those things are important. Kubernetes is a project that is made by really wonderful people with a lot of trust and a lot of openness and a lot of possibility. That's beautiful, and I'm being completely sincere about that. And also, I think sometimes these projects get built assuming that other people also are as good and as lovely and as trusting as we are. And I think that we can see some security implications of that. So let's talk about this a bit. When you're building, who do you build for?
Me.
Do you build for people who share your perspective, for an ideal set of users who use the features that you build in the ways that you intend? If the answer to this is always yes, you aren't designing for all users, and you need to be. So I'd like to talk about a particular set of users who have a very particular set of skills. Let's talk about these users so we can better understand them and their perspectives and design with them in mind. Because attackers are users too, and attackers have user stories. As an attacker, I'd like to tell you some. So, who are attackers? They could be anyone, like this mom right here. They're not all scary-looking stock photos of white boys wearing balaclavas in basements in the dark. Attackers are people, like you. They're not all the same. They come from different places, they might have different skill levels, and they have different motivations. Maybe they're in it for their ideals, or just because they're curious, or for the lulz. Most are financially motivated on some level, whether for bug bounties or black hattery, and their work lives can look more like yours than you might expect. They have bosses, budgets, and deadlines. Advanced persistent threat groups, like nation-states, have been shown to have roadmaps, code repositories, and use software like Jira to track their progress. Across their differences, attackers do share things in common, though. They tend to have similar mindsets and similar methodologies. So let's take a look at those and break them down. So how do attackers think? Well, first let's talk about what you think. When you look at a Kubernetes cluster, what do you look for? If you're a developer, do you look for features or ease of use? If you're an operator, do you look for scalability or observability? Well, attackers look for those things too, but maybe from a different perspective. What do you see here? I can
Two
only
faces.
see some of you, but show of hands. Who here sees two faces? Some of you. Who here sees a face? Also some of you. This picture is called Rubin's vase. It's a classic optical illusion.
Yeah.
Both of those things are right. It's both of them. Same thing, different perspective. Builders and breakers can both
Also
look
looks
at
like
the
a
same
queen
system
chess piece.
and see a different view. So what do you see here? kubectl auth can I -- list, namespace kube system. As a penetration tester, can I just thank the release team responsible for this one? Because it is one of the best innovations in years for making my job easier. Because a lot of things that administrators or operators might find useful can be useful for us too. Before this command up here came out, we had to figure out what permissions we had in the namespace by trying every single call individually. As you might imagine, that took forever and was really annoying to do. This automation makes our enumeration process so much faster and easier for us. A tool like Project Octant that displays the network and relationships in a cluster context isn't only helpful for developers. It can save us hours of YAML parsing too, especially on a black box penetration test when you have no idea what's going on in there. And tools like ephemeral containers and mutating admission control present all kinds of interesting possibilities for imaginative attackers. As Han Solo says, we can imagine a lot. So, same thing, different perspectives. One user might run this command to say, do I have permission to do this? But an attacker might run the same command to be like, what can I do? Because that's useful to know. So, what are attackers looking for when they look at a cluster? They're looking at your cluster not as a list of resources, but they're looking at it as a graph. What is in there? What are the relationships between those components? What are their dependencies? Are there boundaries anywhere of trust? Where do they get crossed? Is there anywhere you can get in? Where can you go from there? Is there anything vulnerable? Are there things in there like Tiller, RIP, with no authentication on it, which I will tell you, as a pen tester, I really miss? Are there admission control on there? Is there, like, at all? What is the admission control, if there is any? Is anything running as privileged? We want to know those kinds of things so that, again, we can figure out how to get in and where we can go. Knowing how a network is laid out, what's happening in a cluster context and what those relationships are, is hugely helpful, because kind of the rough edges and where things cross is often where the attack surface lives.
I've
And
always
frankly,
been fascinated by pen testers
a lot
and
of people
hackers
just
and
aren't using
people that just know how to get into
security
shit.
much at all
I've never
in
been, I've
Kubernetes
never had that
contexts.
mentality.
And so if that's what you find, then you don't really have to go much farther. It's a short day. So what is that methodology? I kind of went through it a little bit, but it kind of has an order to it. So first, you want to figure out what's happening in there. If you're an external attacker, if you're coming from outside, you want to figure out if there's anything exposed, what kinds of services are running, if there's wider internet access, that kind of thing, if there's sensitive data that could be interesting of any kind. And once you figure out what's running, if there's anything vulnerable, once you figure out what's in there, what's connected, then you can see if there's anything that can be exploited to find an initial foothold. Once you get that foothold, you get in, then you kind of look around again, figure out what's going on in there, if there's anything vulnerable, if there's any way to escalate privileges. You escalate your privilege as much as you can. You move as far as you can. And then where do you go from there? Well, it depends. You want to get as far, and sometimes the goals can differ. Sometimes it can look like getting through the cluster. Sometimes it can look like getting out of the cluster entirely, because lateral movement from north to south is a thing if you're leaving cloud metadata in your cluster where I can read it, which I don't recommend doing. So how do we design to
That's a great
defend
picture.
against attackers like me? How can you make your systems something that becomes harder, less legible, and more difficult for me to attack and to move through? First thing I'm going to suggest you do is that you threat model, because every need and every use case is different. You know better than I do what you want to protect and maybe who you want to protect it from. So figure out those assets, look at them from the perspective of who you want to protect them from, and then design for defense around that. So what is your threat model? What are you trying to protect? Who are you concerned about? How are you going to strategize around that? Do this first, because once you do, it can allow you to figure out what's going on and what you need to do in order to protect that stuff. Otherwise, you're just sort of throwing darts at the wall. Threat modeling can also involve figuring out the components in a cluster or a context, and how they go together, how the data flows, where they move, and then figuring out which of those components could potentially have vulnerabilities by themselves or in relation to each other, and basically look at it like an attacker would. There's a lot of information about this. If you haven't heard of threat modeling, there's an acronym called STRIDE that a lot of people use. There's a really good book on it called Threat Modeling, and it's important to do that because it can really help you figure out what's going on and what you need to do. And again, what is in your graph? So it's been said that defenders think in lists and attackers think in graphs. At the diversity lunch yesterday, somebody asked us at the security table how we defined a secure cluster, and I thought it was just the most perfect moment because the defender sitting next to me very enthusiastically responded with a very extensive checklist, and I responded, well, I think that it looks like these things being connected in these ways and in a network, and it looks like a kind of connected area. And I realized that was exactly what we were doing, which was pretty funny. So if you're a defender, if you look at things as lists of resources, that's okay. There's nothing wrong with that. But you need to know that attackers are going to look at that as a connected list, figuring out what those dependencies are, how they connect, what they're doing together. So know what you're running, know what's in there, and understand it well. I got asked a lot this week, how can I learn Kubernetes security? It's so big, it's so scary, I don't even know what to do. So really understand how it works, I would say, is the #1 thing. Kubernetes is made out of containers. Containers are just made out of Linux primitives. If you understand how the tech works, you can understand better how to break it and how to secure it. And if your attacker knows that tech better than you, you're going to have a bad day. So learn how it works from the low levels on. And figure out, again, what connects, what crosses, where are those edges, and look at it the way an attacker would. What would an attacker see? And check your assumptions, because things don't always work the way you think they're going to. I've found, as a penetration tester and as a security professional, that a whole lot of people assume that Kubernetes is secure by default. Spoiler alert, Kubernetes is not, in fact, secure by default. It is possible to secure it, but you have to put in work to do that. But that's actually a fairly common myth, I would say, among end users. And that's a thing that we need to be talking to them about and making sure that they have appropriate expectations about. Because when people put up those defaults, which are open for good reasons historically, the idea is that you want to be able to have granular control according to your own needs and your own use case, which is going to be different. That's OK. But we need to make clear what actually that looks like to end users and what they need to do, because your assumptions aren't always going to be correct. And expect the unexpected when you're threat modeling, because, again, things aren't always going to go the way you think they are. So try to plan for unknown unknowns. And go in there and make sure that things are actually working the way you think they are. Is that thing configured the way you think when you run kubectl auth CANI? When you run the tools that pen testers use against it, does that graph look the way you think it does? It may or may not. It's worth a try. So again, it's possible to secure Kubernetes, although it isn't that way out of the box. I'm going to run through a little bit of a laundry list because I don't have time to cover it, and this isn't really a technical talk. This is a talk about user stories and learning from perspectives. But to cover it, you want to limit your attack surface, and you want to reduce your blast radius. Know what you have running. Again, limit things you don't need. Follow the principle of least privilege. Build in defense in depth. Use admission control, please. So many people don't. Do the basics. It matters a lot. As Brian said, Kubernetes is complex, and that complexity often exists for really good reasons. It has a lot of moving parts, and those moving parts can be dangerous and easy to misconfigure. Understanding how those parts and their intersections can be dangerous can help you be able to configure them better. And understanding how attackers look at those things when they see them is a good step toward figuring that out. So how can you go about increasing that understanding? Make friends. Talk to InfoSec people, both outside of and across your organization. See where security folks are coming from. We're not all trying to be blockers and make your day sad, I promise. Better communication between engineering and security teams can help lead to better processes in general and stronger products. Hire hackers. Encourage security-minded contributors, not just in security organizations or on SIG-Auth. And if you are security-minded, please go across SIGs, because everybody clusters in SIG-Auth. That pun is absolutely intended. And all hangs out together. And I think that security needs to be happening across the stack. Security is everyone's responsibility. As we say in the Midwest, silos are for grain.
Clever.
And get some practice. Thinking like an attacker yourself. You can get in and get your hands dirty. It's not the 80s anymore. You don't have to hack war games in order to get some trying out some hacking skills. You can practice hacking legally by playing capture the flag games, which are not the games that we played on the playground as kids. They're the flags aren't physical. They're in a server somewhere, and you have to compromise the server in order to get it. A couple of beginning to intermediate-ish resources are right there for capture the flag games. You can legally hack them. That's what they're for. I also actually genuinely recommend playing Untitled Goose Game, which is a game called House House, honk, that encourages you to be able to think like an attacker. In this, you play a horrible goose who's terrorizing people in a pastoral village. And you go in, and there's a shopkeeper and a gardener and various other things who have various objects that you're supposed to chain together, despite the fact that they're small and relatively innocuous seeming, in order to be able to properly exploit them to achieve larger goals. It's actually a great game for understanding how to pen tester things, and I recommend it. You don't need to be able to think like an attacker all the time. But if you can step into an attacker's shoes and be able to think like they would, that's a superpower. You can learn from that, and you can build around it. Doing this can help you look at your code and the projects and systems you're building with new eyes. This community is powerful. This project has done amazing things, powered by the people in it, powered by all of you. Our diversity is our strength. Diversity of perspectives, of backgrounds, of skill sets. We all learn from each other all the time. I have learned so much from all of you. Let's keep growing
from
and
hacking
learning
our
together
stuff.
from all perspectives. And let's try to take those different perspectives into account even when they're difficult, because I know that everybody here is wonderful and trusting and lovely, and unfortunately, every user isn't necessarily that way. So if we take those user perspectives into and design for them too, we can actually make stronger products without having to sacrifice what makes this community really good. And yeah, we don't have to think alike. We shouldn't think alike. We can keep the things that work well. We can learn from others to make them work better. And if you can step into my shoes, well, maybe some of you will find out that it's fun to be bad. Together, we can make things stronger and more secure. We can take each other's perspectives into account, we can learn from one another, and we can become stronger together. We can do it. I believe in all of us. Thank you very much.
Thank you, Ian, for that great talk. Our next presenters are Manish Vitolia and Shriyam Koma. Manish is a principal architect at Walmart, helping build next-gen customer-facing applications using modern technologies like Kubernetes and Prometheus. Shriyam is a principal product owner for Walmart Cloud Native Platform and container cluster automation and resilience team lead at Walmart. Today, they will discuss how Walmart is building and rolling out a point-of-sale system on a highly resource-constrained edge computing environment powered by Kubernetes. Please welcome Manish and Shriyam.
Hey everyone, good morning. I'm Sriram from Walmart.
Good morning, KubeCon. My name is Manish Vitolia. I'm not going to make you wait. I know waiting is really difficult. It's very hard, like waiting at the airport to board a plane, or even waiting for a simple download to complete on your laptop. It's really hard. Similarly, waiting at checkout register within a store for a few minutes is like an eternity. We at Walmart believe checkout register as the last and critical step in the customer's journey. We needed to ensure that customer continues to get best experience throughout their shopping journey. Today, we are going to take you through the journey of modernizing point-of-sale checkout application by leveraging Kubernetes and microservices within store.
Well, with that said, who here do not know what or who Walmart is? By raise of hands. I'd be curious to see that. Well, nobody. Great. But anyway, I created the slides, so I'll just go through them. To give a brief history about ourselves, from a humble beginning, as a small discount retailer in Roger, Arkansas, Walmart had opened up thousands of stores, both in US and internationally. Through innovation, we are creating a seamless experience to let customers shop anytime and anywhere, online, through mobile devices, and in store.
Okay.
Our long-serving mission has been to help customers save money so they can live better. We are passionate about this mission. Every technology we create is to serve the customers. Walmart culture is built on 4 basic beliefs. service to the customer, respect for the individual, strive for excellence, and act with integrity. These beliefs has been the recipe of our success for many years. Our culture is the reason we have been able to help our customers globally.
When we say Walmart, the first thing that comes to mind is scale. So let's quickly talk about what Walmart's scale is like. We are just huge. Walmart operates around 11,000 retail stores worldwide. We serve about 265 million customers, both online and in-store, on a weekly basis. And Walmart employs approximately 2.2 million employees around the world. We have significant presence in e-commerce world as well.
And we have not been able to achieve this scale without the help of technology. As an example, in the 80s, we installed largest private satellite system in US, connecting our operations with voice, data, and video communications. Almost a decade ago, we started using RFID to improve our supply chain efficiency.
Come on, guys.
And point-of-sale checkout application within the store
I'm actually really curious about what this is going to be, considering it's related to the scale of Walmart.
We help our customers to complete their last step in their shopping journey, like self-checkout, checkout with me, scan and go, and checkout register.
Our business does drive us to always wanting to provide a seamless, consistent checkout experience for our customers in timely manner, even under non-ideal situations.
So it's important to understand some of the background on checkout application. So last couple of decades, we have been using legacy point-of-sale checkout system, and it's still going strong. This system was built with highest level of resiliency, where required business data was present on the edge. I would say it was our first edge compute we have had, where store-specific data was on in-store servers. So registers will reach out to in-store servers and get data from data located in data center, and any transactions data would be stored and forwarded back to the data center. So more than 4 years ago, we started rolling out our first cloud-native checkout application as a move towards moving from legacy to modern stack architecture, where data and the application was located on cloud. However, with this cloud, application was accessed remotely over WAN network from the checkout applications located in store. This had some limitations, just accessing the applications over WAN network, over remotely checkout applications for customer experience. As an example, regional network issues can happen, and that can happen because of some inclement weather, constructions-related activities in the stores or around areas, upgrades not going as planned, or even some bad changes being rolled out into cloud, and customers are impacted because of that. Because of our scale and large number of customers who walk into the store, even smallest of an impact, like few minutes of an impact, gets magnified across the stores, and it affects the shopping journey.
During a WAN network failure, we fail our business traffic to satellite. With satellite comes latency, which slows down the response in point-of-sale checkout registers. While customers can continue to check out, their response is slow and affects the customer experience.
So looking at the potential problems and fallout with the current architecture, we decided to take our modern application, checkout applications, closer to the customer at edge. We define edge as where customer connects with Walmart stores, where we are closer to the customers, where interactions with customers are taking place, where applications can run in offline and autonomous mode, where application can work with and without cloud. So more than 2 years ago, we started introducing checkout application powered by Kubernetes at edge, where checkout register will connect with checkout application in Kubernetes and get business data from the cloud. This helped in bringing checkout applications closer to the customers within the store. So if the service or the data is not remotely accessible from cloud, customers can successfully complete their last step in the shopping journey within the store, and edge is still functional. However, this solution didn't come without our fair share of challenges that we needed to solve. As an example, first being like, how do we roll out services and Kubernetes cluster across thousands of stores across the world? How do we co-locate the data with the service at the edge? How do we improve the time to market? how to bring the isolation to the services so that application is fault tolerant and does not affect the customer's experience. And how do we improve the productivity so developers can quickly build and deliver to the business?
Apart from this, there were a few more questions that needed to be addressed. How to manage, orchestrate, and configure a given service, along with making sure we keep it secure and achieve resiliency by making best practices default. And biggest of all, given the scale we operate in, how do we manage and keep the deployments consistent across all the stores? After some exploration, we went ahead with microservices managed by Kubernetes as our solution. As everyone might already be aware of, Kubernetes solves orchestration, deployment, configuration, resiliency, and most of all, with a little bit of hard work, security. And microservice architecture helped us to solve few of other parameters as well. Well, with all of that out of our way, came out the hard part, our journey to bring a well-thought solution to life.
So we have achieved a lot as a part of this journey, like localizing the data at the edge, simplifying the consumption of Kubernetes platform in the organization, improving the observability, and making sure that platform is well integrated and resilient enough. That's what our need for the application was. These topics may itself take a dedicated session, but we are going to quickly go through each of them. So when we started proof of concept of Kubernetes almost like 2 years ago, one of the important things that we wanted to solve is like, how do we keep the data from cloud in the store, which is store relevant, always relevant. So we used a Kafka-based architecture to bring store-specific data from cloud for any changes that could take place in the cloud. And that gets persisted on a database located within the store outside Kubernetes cluster on a VMware. For any data that is produced at the store would be stored and forwarded back to the cloud. This is how we synchronize data at edge for any cloud-specific changes. So this is how we kept store as independent as possible. Next in the journey was, how do we simplify the consumption of Kubernetes platform? Kubernetes was new to the company, and technologists were not very well aware of it. And it was very important that we simplify the consumption so that we can build this Kubernetes-powered mindset in the organization, and by reducing the learning curve of the technologist.
All right, now getting an app deployed into Kubernetes cluster
could
be a little painful process with all the manifests that's needed, specifically while deploying to thousands of stores. So
Sorry for the
GitHub's
quality,
model made
guys.
more
They're
sense
only
here.
coming through in
Basically,
480p right now.
Basically, we wanted app team to worry about apps and not about how to get their apps into Kubernetes. We created our own custom CI/CD pipelines, where once app teams drop their code in GitHub, everything is taken care, from building an image and pushing it to Walmart repository, and using the same image and getting the app deployed into Kubernetes using charts. We will notify the app users between each and every stage of these.
Next step in the journey was, how do we improve the observability of the services, the system, across thousands of clusters? This was very important. It was easy to do it in cloud, where you have like few regional compute environments.
I guess each store
here
has
we're
a
talking
cluster?
about thousands of Kubernetes clusters located across thousands of locations, not just in US, even outside US. It was a big challenge. Challenge was, how do we get this logging and metrics data from these stores on thousands of clusters back to our site reliability team so they can work quickly, proactively on the problems that could happen?
Observability is very critical for any application journey. Point of sale at edge makes it even more complex because of the scale that they operate in. All the way from making sure logs are available to getting metrics and being able to start triaging application performance problems. We started using Fluentd, FluentBit to ship our logs to a Splunk cluster, and the same logs were sent to cold storage, which can be retrieved for audit needs. Along with that, we use Prometheus for metric scraping, and for alerting, we use our in-home custom notification bridge. To centralize app metrics across multiple stores, we ship certain metrics to a version of federated metrics backend and store them for a little over a year. That way, we can start mapping the trends post our busy holiday season. We also leverage application performance management for our app triaging.
So next in the journey was, since it's going to be deployed in stores, the question was like, how secure this platform is. And we didn't want it to get our customers with security risks. Another thing was like, how can we deploy these clusters across large number of stores, even in network bandwidth environment to distance locations? And how well integrated this platform is with other open source technology. So when there are some platform support-related issues, we continue to support it correctly and provide best experience to our business.
Like Manish said, security is very critical for point of sale. We started looking at a platform and said to ourselves, app security should be a default offering. From making app communication secure by using Walmart sign sets to making sure secrets remain a secret. We basically wrote our custom operators for these use cases. In order to make sure we sustain in network outages, we fetch the secrets from our Vault instance that's needed for the app and keep them available in the cluster etcd. But as for the certs, we started using Cert Manager with our own custom plugins. This way we can request Walmart sign certs and get them injected into Ingress controller, which in our case is Istio. There are a few remote stores running in low bandwidth in distant locations. And during deployments, we certainly don't want to overwhelm our WAN network and cause any outages. So we implemented a local caching solution with network rate limiting that downloaded or throttled to make sure there's no impact to the store bandwidth. Image layers already pulled as part of the previous deployments became available locally on the clusters. The required layers for the new deployments would get downloaded. By now, everyone should have guessed the next term that I'm going to use, Walmart scale. With the scale we need to operate, we needed a simple way to manage fleet of clusters across multiple stores and other environments. So we built our own custom in-home federated environment where we can manage Kubernetes clusters. Basically, we manage Kubernetes using Kubernetes. We started using federated control plane for various purposes, from inventory management, namespace reservation, app and cluster lifecycle management, to name a few.
This is impressive.
Once we got this platform bit sorted out, the next big thing to tackle was the application resiliency across edge and cloud.
So now everything looked great. We have edge-based Kubernetes cluster and we have cloud. But what happens if edge-based Kubernetes cluster becomes unstable, or even like server goes bad? And we wanted to have a resiliency at that point so that a customer are not impacted. So we built resiliency at the checkout register level outside of Kubernetes. They are going to be making calls to edge clusters over Envoy Ingress. And if the service or even cluster or even the store server is not healthy, it will fail over to the same set of services running in the cloud. So that's how we built a resiliency from checkout register standpoint. But what about application level resiliency? Checkout application is a composition of dozens of microservices deployed in Kubernetes cluster. Same set of services, we deployed it into cloud. We are leveraging Istio service mesh to provide application level resiliency, where our edge cluster act as primary for checkout registers. And as an example, like service A within Kubernetes cluster will be calling service B. It's going to be made over, the call is going to be made over Envoy sidecar.
Very clever.
And service B located in cloud are going to be acting as a secondary.
The beauty of this
backup.
is it could work at any
and when
scale.
service B goes bad, Envoy is going to be sending a request back to service B in cloud.
You
and
can
when
work at
service B
the
goes
smallest shop and
back
still
up,
leverage
it's
this
recovered.
exact architecture.
Envoy sidecar proxy
today.
is going to be switching the traffic back to service B in Kubernetes
Very,
cluster.
very clever.
This is how we make sure checkout system is resilient to the problem that could happen in our system, and we continue to provide best experience during last and critical.
So basically, locally, if service A goes down, Envoy's going to, the sidecar is going to try and service B. If that's down, it's going to send it up to the cloud. If all of the whole site's down, it's going to send it directly to the cloud. The point of sale register is never down.
Which showcases the power of Kubernetes in terms of integrating with proprietary and open source tools using custom CRDs where required.
Now, so far, we have rolled out to around 50 plus stores in US and one each in China and Japan. And along this journey, we had a lot of learnings.
I bet.
As an example, like first being, integration is time consuming. We operate in brownfield environment, and we have to integrate our system with this new Kubernetes platform with the existing system that exists in Walmart. And it takes more time even to move services from cloud to edge compute environment in Kubernetes. It's not easy to lift and shift the services, even for the simplest services. And data needs to always follow the service. And one of the important thing is like edge environment often require different strategies and different platform component considering physical and technical constraint environment we operate in.
Well, like people earlier called out, make best practices default by leveraging templates and charts, which will help with easy consumption.
Yeah.
Automate common workflows using orchestrators and operators where necessary. But last but not the least, for edge, be prepared for unexpected. For example, bandwidth limitations that was called out earlier.
And our journey just doesn't end here. We have a lot to achieve. And there are a few open challenges that we wanted to solve. As first being providing data persistency within Kubernetes cluster. Currently, we are persisting data outside Kubernetes on a VMware VM located within stored servers. We wanted to bring it inside so it's more simplified. Next being is we wanted to reduce compute in the store environment and being able to run Kubernetes in the smallest footprint as possible. And third being regionalizing the deployment. Now, today we are deploying all our services and Kubernetes cluster from US cloud region. And due to distance location, deployment to our market store has been time consuming, and it affects time to market. So we wanted to bring market proximity for deployment and make our market self-enable.
Yeah, that's a good goal.
With this, we'll wrap up. Thank you for having us here. We are hiring, and we are hiring at all locations.
Thank you all. Thank you for listening to us. Have a good day and enjoy the San Diego weather.
So, that's good stuff. I love a good architecture talk. That's my jam right there. I love that kind of stuff. I want to pick that apart tomorrow. We'll pull those slides back up and look at it again.
Of the event, and touching on how the project and use cases advancements
quality just got
allow
really
our
bad on
end-user
the live stream, guys.
community
Sorry about
to do
that.
more advanced things.
There it goes. It's better now.
And maturing our ecosystem overall is Anna Medina and Lenny Sharp. Oh, sorry, one second. Just 1 second. We didn't do this right. Let's do this correct. Anna is currently working as a chaos engineer at Gremlin, helping companies avoid outages by running proactive chaos engineering experiments. Lenny is a director of engineering at Target. Today, they will discuss how Target and Gremlin have built a resiliency engineering capability that enables teams to build more reliable systems. Now, actually, extra loud claps this time. Please welcome Anna Medina and Lenny Sharp.
Good morning. Thank you all very much for coming to our keynote. And once again, thank you KubeCon for having us. My name is Ana Margarita Medina. I work at Gremlin. And here with us, we also have Lenny Sharp. Today, we'll be talking about finding the joy in chaos engineering.
So as you've heard, my name is Lenny Sharp. I'm the Director of Engineering and Infrastructure Operations at Target, and I lead the Resiliency Engineering Enablement team. We're responsible for driving our disaster recovery and chaos engineering capabilities.
As I mentioned, I'm a chaos engineer. I work at Gremlin. I break software. I wonder how things are resilient, how things are reliable. I got to do this prior to joining Gremlin at Uber, where I did chaos engineering, and I was helping Uber move to the cloud. Other things that I love doing apart from working in tech is trying to bring more diversity into the tech space, especially people of color. And other things that I love doing is also helping break the stigma around mental health. Mental health is real, yo. But to set the stage today, I first want to go over some definitions of the topics that we'll be talking about today. So, first of all, what is chaos engineering? Chaos engineering is thoughtful, planned experiments designed to reveal the weakness in our systems. If you're wondering how you do experiments, well, if anyone remembers a scientific method that they learned when they were growing up in science class, we use exactly just that. We examine our systems, and we start by forming a hypothesis. You don't need to know exactly how everything works. You do this in a team setting. After coming up with this hypothesis, you want to go and actually implement this as an experiment and test it. After you see this experiment happen, you want to analyze those results. This is also the part where hopefully you would have come up with an abort condition. If that abort condition would have happened as you were going through your experiment, you would have safely halted that experiment. If that experiment was successful, well, you want to go ahead and expand that scope. Is what we like talking about as blast radius. That could be the amount of hosts or containers that you're running an experiment on. And then you also want to expand the magnitude of your experiments. That means how the strength of your chaos engineering experiments. And we'll see that later on as we go through our demo. But after you do the experiments, the other thing you need to be doing is actually sharing your results. This is about building a culture around resiliency and letting folks know how your applications were breaking and also giving back to the community. The other term that we'll be discussing today is game days. Game days are a dedicated time to come together to gain insights. It's an opportunity to execute one or more experiments. So if you were wondering why you should be doing something like chaos engineering, well, that is because the cost of downtime is extremely expensive. Can I go back to the last slide? Yeah. And that video should play too. Thanks. Well, as you can see on the video behind me, we see the cost of downtime that is happening if any of these e-commerce websites were having an outage right now on a non-high peak traffic day. As you can tell, is extremely expensive. That complexity of retail tech only continues to grow, and with that increases the chances that system disruptions or even downtime can occur.
Yeah.
This is why we are here today. We know it is not a matter of it is not a matter of it's actually going to happen. It's a matter of when it's going to happen.
There's a reason Netflix created Chaos Monkey in Amazon.
But it is a capability worth investing in. And if you're looking to improve
Constantly
your
test
reliability and
disruption.
resiliency, you want to make sure to do this.
So as Anna alluded to, downtime for any organization isn't good, especially retailer and heading into one of our busiest seasons in the next couple of weeks. So this is why we started our journey into chaos engineering at Target. We wanted to get ahead of issues before they became outages. But as we were growing, we were also up against a major transformation at the time a few years ago when we started this journey. Terms like chaos or IT resiliency were more buzzwords. They weren't concepts anyone wanted to get behind at the time. So we needed to move forward. No one was asking us to do this. And when I was thinking back to when this journey began, I thought about a quote that one of my mentors used to use. And it was, "Don't wait for your ticket to the dance, just show up." And we needed to do that. Having the confidence to do something in a large organization that hadn't been done wasn't going to be easy, but we had to embrace the challenge. I had a team of engineers that were very passionate and highly skilled that wanted to make this happen, and we did just that. So Target is big. The sheer size and scope of the organization and the tech that we use gives us some unique challenges. With over 1,800 stores and 40 distribution centers, with Kubernetes clusters running in both stores and DCs, it's very challenging for us to have a one-size-fits-all approach. So as we started thinking about chaos engineering, we had to take a very thoughtful approach. How many of you have been told something's not going to work when you've had a great idea? I think everyone can relate to that. Well, we had an uphill battle ahead of us. Chaos engineering was still a new term, and if people heard of it, they considered it more of a load testing or performance testing type capability. Across Target, we didn't have good steady state. As I mentioned, we were going through a major technology transformation where we're implementing more state-of-the-art technologies. Leaders were skeptical, and if they had every right to be, because we were competing for resources when we were trying to break things and they were trying to rolling out new features. But we had this opportunity to help them with everything. We knew chaos engineering would give us the ability to help better understand dependencies, improve our observability, and overall better understand how our systems would operate.
So I mentioned I worked at Gremlin. Gremlin is the resiliency company that offers a chaos engineering platform. And Target turned to us to figure out how they can do chaos engineering experiments in a precise, easy, and safe way.
Cool.
So we built a journey and a roadmap to make this come to life. At first, it was about just developing the strategy and introducing it to leaders across the organization.
Love the Gremlin logo.
From there, we started to learn and iterate. We wanted to do one game day a quarter, and then we wanted to move into one game day a month, now doing them generally more than a couple a month, and even doing self-service. Our goal as we continue to move forward is to improve the overall culture and adoption of chaos engineering in the organization. And my team is laser focused and increasing the amount of automation and scale and scope as we head into 2020 for our chaos experiments. So in the beginning, it wasn't easy. We had to look across the organization and find teams that might have already been doing chaos experimentation. In this case, we reached out to our release and runtime engineering team that was doing fire drills. They would have engineers manually break services and let more junior engineers have to diagnose and detect what was going on. This was great. Our team got to basically see a game day happening that wasn't formally a game day. It was just teams coming together to better understand their systems. But the team had one problem. They were manually doing this. Having a tool or more tools to use to increase the automation around this would improve the amount of time they were spending on these exercises. And that's where we came in. So we started to run formal game days using tools. In this case, it was a team that was focused on our supply chain organization. They were using Kubernetes, and it was a great opportunity because the senior leader would kill pods randomly and watch his team respond. Not something those engineers enjoyed. So in this controlled environment, we're able to find and outline hypotheses and attacks so they knew what they were getting into. We decided that running this game day with them was going to be impactful. And so we found a couple great findings. The first being with auto-scaling. The team thought everything with their Kubernetes clusters was bulletproof and super resilient, but they're able to make minor tweaks moving forward and apply those to other applications that weren't tested during this that were in production. After this, we're able to take this success and continue to grow the program. So we've done our first official game day leveraging a tool, and it worked. We're experts, right? That's what we thought, and we needed to act that way. But we still had a long road to go. We didn't need to go backwards. We needed to look forwards. And in this case, we wanted to continue to market and share our results both internally and externally at Target. And we wanted to develop our own platform to continue to grow and conduct more attacks. So my team developed TRAP, Target Resiliency Automation Platform. TRAP is a platform used to conduct chaos experiments, leveraging software as a service and open source tools. And in the future, it's going to enable us to automate our disaster recovery exercises. We've integrated with other Target services to provide notifications when experiments are happening so that teams that are running other applications can understand what's going on. Soon, we're going to automate gathering other metrics from other dashboards into our platform, which will allow for quick sharing of the results of these experiments. We built TRAP with one focus in mind: to find faults before they become outages and to create an experience for our engineers that make them want to use this tool.
I'd be curious to hear if it's different than what they did with Chaos Monkey at Netflix.
So we want to have some fun with it. We used to go to different demo days and market TRAP and what we could do with it. So the team came up with this menu concept. As you can see, the various specials are the kinds of attacks you can run. We were able to give this out to a lot of different engineers, and they could even Slack us what types of attacks they wanted us to run with them. Apparently, latency is the most important attack to run, and it's the spiciest, as you can see as well. Then, just recently at a demo day, the team got very creative and started looking at trick or trap. We took the menu concept and created a spell book. Really, really happy with how this turned out, and we could have curses or hex acting as attacks on systems. Just another way to be creative and to market chaos engineering in our organization.
Love it.
As I mentioned, we have demo days where thousands of engineers at Target get together, so we continue to market that. We leverage hackathons as a way to break systems as well as look at integrating other systems at Target with TRAP. We bring in industry leaders to come speak at our internal events so we can validate the path that we're on. And finally, we co-host the Twin Cities Chaos Meetup Group, where we bring in experts across the US to speak about chaos engineering to get other organizations in the Twin Cities more information about how they can grow and develop chaos engineering capabilities at their organizations.
So Lenny just mentioned the Twin Cities Chaos Engineering Meetup, but it doesn't just stop in Minneapolis. There is chaos engineering meetups happening all over the United States and across the world, all the way from Colombia, all the way to London, all the way to Australia. We foster these online communities too, but we also want these folks that are living all over the world to come in IRL, AKA in real life, and get together to share their learnings with chaos engineering. So just 2 months ago in San Francisco, we held the 2nd annual Chaos Engineering Conference. We brought together 600 minds to get some hands-on learning experience running chaos engineering on Kubernetes, and then they also got to learn with various folks in the industry that are practicing chaos engineering at their companies. Some of those minds included folks that worked at MailChimp to Expedia, and they got to talk about breaking through in their chaos engineering practice. With this community, we also like talking about open source and how we're taking our learnings to make other software more resilient. So today, I'll be doing a little bit demo of using chaos engineering. I'll be using the Google Cloud's platform microservice demo. It's a very typical 10-tier microservice. As you can see here, we have an architecture diagram. We have various applications that are running. But first, I want to show you what the steady state of this application looks like. We're able to go on to the site, very typical like in e-commerce. We can browse it. We can go look for an item that we're interested in shopping. I'm going camping next week. I want to buy 3 mugs. I can go ahead, add that to my cart. Then I want to go browse more products. And I want an expensive camera, because why not? I've added that to my cart. I see all the payment information is right. I place my order. Boom, my order is complete. That was easy.
Hipster
But
shop.
now I actually want to do chaos among this. So I'll go over to Gremlin, select attacks, create a new attack. Then I'm going to go over to the Kubernetes tab. I want to choose the cluster that I'm using today, which is running on Amazon EKS. Then I want to find the namespace that this has been deployed on, which is the default namespace. Here, now I see all the deployments under this microservice. And I want to start with targeting the product catalog. I would now like to add some latency to that experiment. So I'll go over to the network side, then I'll select latency, and I'll start by saying that I want to run this experiment for 120 seconds. I want the magnitude for that experiment to be injecting 1,000 milliseconds of latency. So I'm now starting my experiment, but I want to talk about the abort condition. I'm now injecting 1 second of latency. I expect my application will be usable by users, but if I see that latency be more than 1 second, I want to go press what we call the big red button in chaos engineering and stop that experiment. So we'll go and actually select the details of this attack. We see that it's starting to get ready for running. We'll go back to our demo application, and we'll try opening the vintage typewriter. And this is starting to look that it's actually taking a little bit longer than just 1 second to run this experiment. Let me do one more try. Let me add this to my cart. That's definitely more than 1 second of latency. This is actually affecting our customers, and we were doing this in production. So you know what? I'm going to actually go ahead and say that I hit my abort condition. I want to go press that big red button and stop this experiment. I think that this application is not handling 1,000 milliseconds of latency quite well at all. I've halted it, and this experiment is now rolling back. So with this, I have found that if some latency was to happen in my cluster, in my application, maybe I'm realizing that things are not as decoupled as I thought. I was expecting 1 second of latency across those calls. There was a lot more than that. So with that, I want to say that we have been researching a lot of failures and outages that have been caused as folks are running Kubernetes at a large scale. And with that, we've seen that about 25% of these outages are happening just because folks are not auto-scaling things at all. They're not doing any horizontal pod autoscaling, and they're not actually even autoscaling on the resource layer on the nodes. So we strongly recommend for folks to be doing CPU attacks to actually test how the resources on Kubernetes are getting affected. And if you're setting resources limits, are you actually going on your containers and actually testing them? The other thing that we've also seen is that a lot of failures on Kubernetes actually happen due just to the network. And those are things that include attacks such as latency, packet loss, black hole. And this is also a great way to actually see how you fail when your dependencies are going wrong. How is your application handling failures when your dependencies go down? And is your application actually handling errors due to latency?
I really like this.
The other fun one that we actually see is that a lot of us are just using Kubernetes because it's super resilient. But we actually don't think about what happens. Let's say our container was to actually shut off or die, and we just assume that another container is actually going to come back up. Well, when that container is getting respawned, how is your application actually loading during those few seconds that it takes?
You should have more than one already running.
So for us, the road ahead means more testing. We need to continue to test to look for vulnerabilities before they become outages. I challenge my team to think about what are the big pigs flying, and then how do we build a roadmap to get there? So for us, we want to see more increased OKRs around experimentation. We want to have more accountability to ensure teams are testing on a regular basis, as well as moving into production with continuous testing occurring all the time. We want to increase that overall scope and scale, ensuring that our most critical guest-facing applications are having chaos experiments run to identify weaknesses. And ultimately, we want to see incident data blended with this experimental data so that we can proactively identify what types of attacks should we be running in production on a continuous basis.
I love the road to pig flying. That's awesome.
So as a kid from Buffalo, I had to throw in a Buffalo Bills reference and a famous coach from Buffalo. So whether you're rolling out a new chaos engineering capability in your organization, or you have a super resilient Kubernetes technology, or you're trying to implement something that hasn't been done, there's going to be failures, and that's okay. We need to embrace those failures and recognize that they're going to happen, and that's fine. But enjoy the successes along the way as well.
And with that, we want to share that failure is part of the success. We are all learning from our failures. So we would like to invite you to come and join the chaos engineering community that has over 3,500 folks that are just getting started in their practice to some folks that have been doing this for 10 years. We would like to continue sharing our failures on our successes that we've had with Kubernetes, just to continue making Kubernetes more resilient and continue helping build a resilient internet.
So thank you for listening to our presentation today. Hopefully there's something you've gained that can help make your systems more resilient. If you have any questions, feel free to reach out to Anna or I, and we can help you with more. Thank you.
Thanks.
Bravo, well done. Love good DR and resiliency conversations. Jesus, their music's loud. Just awesome. Definitely going to check out the Gremlin tool as well. That looks awesome.
All right. So I'm going to do the speaking because Vicky licked the handles, and I said never lick the stair handles when you travel. So Vicky's a little under the weather, so she's just come up here and you can animate what I'm saying. All right, so our next stop for KubeCon plus NativeCon is in Amsterdam on March 30th through April 2nd. The CFP is open till December 4th, and sponsorships are still available. After Amsterdam, we head back to Shanghai, July 28th through the 30th for KubeCon Cloud Native Con Open Source Summit. The CFP and registration will open in January. Sponsorships are available. So save the date. The next KubeCon Cloud Native Con North America will be in November on the 17th through the 20th in Boston.
No more San Diego. They're going to Boston in November?
Go Boston.
You out of your minds?
In addition to the upcoming KubeCon events, we encourage you to attend our newest series of events, Kubernetes Forums. The first will be in December 9th in Seoul, Korea, and December 12th through 13th in Sydney, Australia. Our next set will be in India, starting with Bangalore, February 17th through 18th, then Delhi, February 20th to 21st. The schedule will be announced in December. Sponsorship's still available. There will now be a coffee break in the sponsor showcase for coffee, tea, water, and snacks. Our last day of sessions will begin at 10:55. Thank you from Vicky and I, and we'll see you at the next event.
Well done, guys. Well done. All right. Let's get that off the screen so we can chat for a minute. Lots to discuss here as we close things out for KubeCon 2019. So, first of all, thanks everybody for joining in on the stream. Those of you that were able to attend, those of you that are watching the VOD after the fact, these will be up for another 2 weeks as Twitch keeps them up for 14 days. I'm going to download them and put them on our new YouTube channel, the new DatacenterDude YouTube channel that's coming soon. It's got some old stuff on there, not really that much yet, but we're going to be bringing that up as well because I know a lot of people come back and they want to watch these live streams and commentaries and things like that after the fact. Let me make sure I get the right screen going here. Oh, man, this is all messed up. Oh, well. We'll just leave that one there for now. So, yeah, make sure you guys are following the channel up top by clicking the little heart and subscribe to the DatacenterDude YouTube channel. We're going to be doing all kinds of good content coming up very soon. In addition, we're working on building and curating some ongoing recurring content for twitch.tv/NetApp, our new official NetApp channel that was launched a few weeks ago at NetApp Insight with our keynote there. So we're going to be doing things talking about the NetApp hardware universe. We're going to be talking about things that are specific to anything with ONTAP and anything you can do, architecture discussions and design discussions, PM updates, roadmap updates, things like that that are going to be happening over there. That's going to be all contained for ONTAP. That's going to be one show. We're talking about, trying to come up with a clever, cute name that's going to be something to do with cloud. So you definitely want to make sure you're following twitch.tv/NetApp as well, because a lot of that stuff is going to be launching within the next month or two. So keep that kind of stuff in mind. We're new to this live streaming thing, and it's something that I've been trying to champion for the last couple of months, and it's been facilitated, and they've been giving me resources and everything. So they're all in on it as well, and I can't wait. So thanks for hanging out, not only for Insight, guys, but for Ignite a couple of weeks ago and for KubeCon this week. We also had Google Next London happening this week. So many shows. It's the most wonderful time of the year. And that don't mean Christmas. That means fall trade show season. We're in the midst of it as we speak. We're through the Insights. We're through the VM Worlds. We've gotten past KubeCon. Now it's time for, I think, Gartner Data Center. We're going to have AWS reInvent here in a couple of weeks. Lots of good stuff as we head into the holiday season. Thanks so much for hanging out, guys. We will be on tomorrow for the big weekly stream right here, twitch.tv/DatacenterDude. Make sure you're following the channel. And again, head over to youtube.com, search for DatacenterDude, and you'll find me over there. Just look for the double D logo. That's the right one. And I'll put some links down in the, if you're watching live on YouTube right now, you should be able to, on Twitch, you should be able to scroll down to the panels underneath, and you'll be able to see the links directly to the channels there. But I'm Nick Howell. Thanks for joining in, guys. We will see you guys tomorrow for our big Data Center Dude stream. We'll continue our build-out. We maybe revisit some of the content from Tech Field Day last week that we didn't get to watch and talk about some more. But thanks for tuning in. We'll see you guys tomorrow.